Hello and welcome everyone to today's webinar on secure software delivery with DigiCert and Oracle Cloud. Thank you so much for joining us. My name is Tara Van Cleve and I am a marketing event manager for the developer initiative here at Oracle. Today, we're excited to show you how DigiCert and OCI can help you automate many of the tedious aspects of software security into automated steps of your CI/CD pipelines. We'll also be recording the session, and we will provide the replay via the same email address that you registered with for today's event. If you have any questions during the webinar, please drop them in the Zoom chat and the Zoom Q&A areas, and we will be ready to help answer them. We've also set up a channel in our developer public Slack called Webinar Secure Software Delivery that you can access at the QR code here or at bit.ly/odevrel_Slack. And we'll leave this channel open after the event to contact us directly and with any questions that you may have, and to share resources and upcoming events with you, as well as the event replay. So today's webinar will be presented by Eddie Glenn, Product Marketing Manager, Software Trust at DigiCert, Dave Roche, Product Manager, Software Trust at DigiCert, and Eli Schilling, Developer Advocate in the Cloud Native and DevOps space at Oracle. So without further ado, I will first hand it off to Eli to get us started.
Awesome. Thanks so much, Tara. All right. Thanks for joining us today, everyone. Super excited to have the opportunity to chat with all of you on secure software delivery, and also to partner with my colleagues here, Eddie and Dave. I'm Eli Schilling. I've been a developer advocate here at Oracle for a little while now. I've been with OCI for many, many years, and it's been quite an adventure. I had a lot of fun with this. Before I dive right in, I'd like to have Eddie and Dave give a quick intro as well.
Thanks, Eli. Yeah, hi everybody. Dave Roach, as Eli introduced from DigiCert. I've been working with DigiCert now for over 12 years, again, primarily in the software security space, and delighted to get to speak with Eli and Eddie here today about how Oracle and DigiCert are working together to help solve those problems for you.
I am Eddie Glenn, really happy to be here. I've been with DigiCert now for about a year, but I've been in software development for over 25 years and software security for the past 10, and I'm really excited to be here too.
Fantastic. So I always like to start by talking about Oracle Cloud in a nutshell. And of course, this would be me in a nutshell, but we're here to talk about cloud and secure software delivery. So we kind of talk about the whole stack of security in our cloud ecosystem, from securing the network layer, securing our data, our infrastructure, and we want to make sure that we build security into every single layer, and that includes the software delivery layer as well, which we're going to get into in a lot more detail. But I just want to quickly start with some of the key benefits that Oracle Cloud has to offer, and that is, on top of that built-in security at every single layer, plus things like cluster networking, things like non-blocking networks to ensure high performance, complete throughput, off-box virtualization to ensure higher levels of security within that infrastructure ecosystem. And then one of the, I think, unique to OCI is this notion of flexible infrastructure, the ability to provision resources only as much as required, so as much CPU, as much memory, as much storage performance. That way, provision or overpay for those resources in our cloud ecosystem. If we just kind of scratch the surface in terms of what the app dev ecosystem on OCI looks like, support for very basically any language, Python, Ruby, TypeScript, C++, Rust, PHP, and of course we've got Java there, which we'll dig into a little bit more detail. In terms of kind of the app delivery space, Oracle is big on freedom of choice. So while we do have a DevOps, a CI/CD tool built into the platform, we do want to encourage folks that are using existing or third-party tools today, bring those over. They work with our ecosystem, they work with our DevOps tooling, and as you'll see here today with DigiCert, there's the ability to integrate multiple tool chains or tool sets together to give you the best, kind of the best of both worlds, the best possible solutions. All of that's built on top of our cloud infrastructure, so compute, storage, networking, load balancer, edge compute, and various capabilities there. Also, while providing a full suite of security tools, from identity and access management to monitoring, CloudGuard for built-in governance and compliance, Key Vault for for encryption and secrets management, and so much more. Another key benefit I always like to chat about, Kubernetes, very popular for quite some time. As you begin to scale your containerized workloads, management of that Kubernetes ecosystem does get to be a bit of a challenge. So we've tried to simplify that as much as possible by providing a managed Kubernetes service. It's basically built on the same open standards that Kubernetes has been built on. So no heavy customization, no vendor lock-in. It's Kubernetes with a management wrapper built around it. It has all of the flexibility, the extensibility that you come to expect, a wide variety of advanced security features like the ability to provision private clusters and private container registries. So they're hidden, stored away from the public domain where the attack surface is basically mitigated completely. And OKE is completely integrated with the rest of the OCI Cloud platform. That is to say, the identity and access management component, being able to do role-based access control inside of Kubernetes using your IAM users and groups, integrated with our CI/CD toolchain. I mentioned OCI DevOps a minute ago, integrated with encryption, governance, and a whole swath of other OCI Cloud services. So it's really easy to deploy your applications into a containerized environment and leverage the entire suite of OCI tools and services. Now, I mentioned the OCI DevOps platform here, and this again, back to that notion of freedom of choice. We wanted to give a full suite, a comprehensive suite of continuous integration and delivery tools, but that's not to say that if you're using something like Jenkins or Spinnaker or another continuous integration tool today, you can continue to leverage that to manage your source code, run your build, your test, integrate things like the products that DigiCert's going to talk about here shortly, deliver the eventual artifact to a centralized container or artifact repository, and then use OCI DevOps to pick that up and continue your deployment process. Deploy to dev, run your integration testing, maybe do some traffic shifting if you're running a canary or a blue-green deployment strategy. You can pause for approvals and then continue that delivery, the deployment of your application to any one of the compute ecosystems within OCI, whether that's standard compute, container engine for Kubernetes, serverless functions, and one icon that's not there is the container instances, which is kind of the serverless container management ecosystem on OCI. So as I mentioned, the OCI DevOps, it's a serverless DevOps tool, basically. There's nothing to manage or maintain. All of the resources are encapsulated, included in the service, essentially free of charge. There's a runner that we deploy to do the build and test and deploy, but again, it's pennies to get that rolling. We can do this to securely deploy our applications inside the Oracle Cloud ecosystem, whether that's compute, OKE, container instances. It gives us that native integrated security to make it more effective and more efficient than some of the third-party tools. And because we built this to be flexible, to allocate that freedom of choice, you can integrate with existing CI/CD tools. You can leverage third-party security tools, as I mentioned, like what Dave and Eddie are going to chat about with us today on the DigiCert side of things. We want to make sure that we mitigate potential exploits anywhere in our software supply chain, and utilizing the best of breed tools to do that is what's going to help us solve and address some of those potential challenges. Now, just really quick recap, because we just released Java 21 a couple months back. As many of you may be aware, Java's been kind of the predominant development language for many, many years. Continues to be one of the top languages in use for enterprise and other technology development today. And one thing I found is interesting, and there's a recent report that came out about some of the open source projects and initiatives, and Java continues to be one of the top languages used even for new CNCF projects. So right up there with with like Python and TypeScript and others. So Java, organizations continue to rely on Java because it's open, it's transparent. We continue to innovate as a community around Java because it is open source, providing continuous functionality, feature evolution, and predictable evolution of the Java ecosystem. Now, we're here to chat a little bit today about potential attacks on our software supply chain. As developers, we pretty much focus on writing code and obviously ways to build and deliver that code. But as you've kind of recognized on the screen here, over the past many years, attackers have been focused on infiltrating the entirety of our stack. That's all the way up to the software supply chain. They're finding new and innovative ways to sort of inject or intercede into our software delivery, software supply chains. So we need to have tools and solutions to help mitigate and address, again, every layer of our potential threats to every layer of our supply chain. So Eddie, why don't you tell us about why developers need to be concerned about software supply chain attacks? Let me pass it over to you.
Yeah, great. Thanks, Eli. That's a great handoff. Yes, supply chain attacks have been in the news, continuously for the past 5 years. And as Eli mentioned, every time we figure out ways to stop one attack, attackers find new ways to do it. Probably the most notable one was the one that happened with SolarWinds a few years back. And when we look at some of the things that cause these challenges, these are some pretty impressive statistics that come from Gartner and Forrester. 45% of organizations out there will experience some level of software supply chain attack by 2025. 633% growth in attacks from 21 to last year, 2022. And part of the one of the contributing factors is the amount of open source code, which is great from a development standpoint, but it does open us all up to vulnerabilities and attacks. And that is 99% of code bases contain some level of third-party component or open source. So all of these things really start to contribute to the challenges that we see our customers face every day with protecting their software supply chain. And I know, one of the things that I experience a lot when I'm talking to customers, if I'm talking to an individual development team, and I know a lot of you are individual developers, these may not be issues that are at the forefront of your mind. You're probably focused on how do you get the next capability into the next sprint in time, and your pressures on doing more faster, and that focus sometimes takes focus away from security. And I really enjoy talking to both the development side of the house, and then I'm sure you have security teams within your organization. And DigiCert looks for ways for which we can bridge both of those. So when we think about enterprise software supply chain needs, let's focus on your side of the equation first. What do you need to help with software security? So you need a convenient and easy way to access any kind of security tools that your organization puts into place. They have to be automated, because I know definitely with today's modern software development, if a security mechanism is not automated, is not part of your integrated build pipeline, it's not going to be done. And it needs to integrate with the current set of tools. And that's what we're so excited about with our partnership with Oracle, is that with that, DigiCert solutions do integrate directly in with the Oracle platform. And then, if I look at the other side of the equation, security teams, what do they need? As we're going to see in the next slide, they're dealing with lots of different teams across their organization, software development teams. So they need something that's consistent, that is consistently enforceable. They need to be able to define policy. They also want automation so that they can be assured that it is everyone's following their policy. And then they need enterprise visibility. So, whatever your team's doing, they need to have visibility into that security measures. They need to have security visibility into measures of all the other teams across your organization. So when we look at this kind of tug and pull, DigiCert wants to come up with a solution that satisfies both of these very disparate needs. And when we look at a typical enterprise, this is kind of the environment that we see. So for your particular team, maybe you're developing Java, it seems simple. And one aspect of software security is code signing. So you may need code signing keys, code signing certificate, and it doesn't seem like it's that complex of a problem. But if you step back and look at the big picture across your enterprise, your security team is dealing with lots of different software development teams, and they're probably using a disparate set of of tools and workflows and methodologies and programming languages, et cetera. And then you look at teams like the PKI team, very likely responsible for obtaining code signing certificates and managing keys for you. They're trying to support all of you globally. Then there's a security team that needs to be aware of what's happening from a software security standpoint, but they don't necessarily have that visibility. And they may have policies that they want to consistently enforce across all of your teams. They don't have that capability either. And then there's probably a tiny group that I know that's usually not pleasant to work with, but it's the compliance team. And they need records, they need data to show that they are fulfilling any kind of regulatory requirements. If there is a breach, they need to have records to show, how did that breach occur? And then finally, you have your IT department who really doesn't have a way to connect in all the roles and people across the organization with an integrated security solution. And that's what DigiCert's able to bring to the table and offer both all of you as developers, along with PKI teams, security teams, and compliance teams. And Dave's going to spend a lot more time talking about the solution later, so I won't spend time here, but basically you can see from this slide, we take all that complexity out of the picture and we replace it with an integrated platform that works with the tools that you use today, it automates with the tools that you use today, and it provides those assets and that control and that visibility that your security organization needs.
Thanks, Eddie.
So I'm going to turn it over to you, Dave.
Perfect. Nicely teed up. And so as we talk a bit more about, what Eddie's kind of positioned here with us is good to kind of, again, consider where all of this fits into your software supply chain. And, we like to look at it from a perspective of, developers being the ones that are creating the innovation, but that there is a sequence of steps that are repeatable all the way until that software gets out the door, and whether that goes to partners, into a cloud, onto devices, but somewhere it goes to your customers, end users, end devices, where it's going to run and provide those services that your end users will consume. So in between, that writing of the code and that software getting deployed securely and in a transparent way, we have buckets of things that are happening repeatedly in the CI/CD. So there's the steps that are going to keep your source code and the source stage of the life cycle of the software secure. There's the build process where you're converting all of that source code into your artifact, your binary, your app, your container, whatever form that is. And then the packaging up and the distribution of that in a way that can be verifiable and transparent and ensuring that it's tamper resistant. And being able to introduce secure checks and balances throughout that process and in between some of those steps is really what's going to help ensure that you're not going to experience these events that Eli teed up at the start, where you find that malware or vulnerabilities becomes part of your software, which is then problematic later from both a remediation perspective, but also from a reputation perspective. So our solution, which is called Software Trust Manager, focuses in on 3 key areas. And again, these are integrated into the tools and services that you use today. And they focus in on 3 key deliverable areas. Number 1 is around threat detection. So this is about ensuring that the software that's being produced is free from malware, vulnerabilities, and therefore you have great software assurance around what you're producing. The second then is around enabling the secure signing of that software in the build process so that you're making it tamper resistant. When you do distribute it, that nobody can inject anything into it, that they can verify it comes from the right source, and then you can manage the life cycle of that software in the wild. And the final step then Again, a little bit more current in terms of the securing your software is the introduction of software bills and materials, which are now becoming ever more pertinent in a lot of different industries, but to bring transparency to software. So what is your software made up of? Being able to verify that on the way out the door before you release it, but also giving transparency to your partners, your customers, so that they can make decisions based on what your software is comprised of, giving them the ability to detect what libraries you're dependent on, what third-party dependencies you have. And so let's look at each of those in isolation and dig a little bit deeper into them. So we're going to first look at code signing. So code signing has been around almost as long as Java. You know, from a verification and identification perspective, Java-based code signing has been one of the founding, I guess, drivers for establishing code signing across all of the private and public ecosystems. And it's focused on two core things: identifying the author and ensuring then that the content itself has not been altered or corrupted, right? So the making of your software tamper-proof or tamper-resistant. And it's fundamental, you know, that you do that, because otherwise software could be coming from anybody, and it gives the ability for bad actors to change what your software is comprised of for malicious reasons. And you know, what's the purpose of code signing? So again, it acts a bit like a birth certificate, and it can be something where the trust is established both in a private ecosystem or in a public ecosystem, such as distributing something across the web. At its primary level, it's about a key pair, a private key and a public key, protecting that private key so that nobody can sign on your behalf or use your assets to sign software and inject something and make it look like you. So it's really critical that the private key of the key pair is highly secured. And recent changes in the CAB Forum, which is the governing body that looks after public trust TLS and code signing, have in June 1st of this year implemented an enforced change where you can no longer have that key pair unprotected on a build server, in a CI/CD pipeline, in a secret store, which isn't compliant with FIPS 140-2 regulation or Common Criteria Level 4. So essentially, they've now made the requirement for all private keys of key pairs to be protected to FIPS level or Common Criteria standard, meaning that they are generated and stored in a hardware device somewhere down the chain. So that doesn't mean you can't use a HSM as a service like OCI can provide. You very much can use those, but behind those HSM as a service, there is a hardware farm of HSMs that are providing that protection at the compliance level. And so when you're signing software, again, the certificate is associated with that public key. The public key is embedded in the certificate, and it's the private key that's used to sign the software. And in the case of Java, like Eli talked about, also with Authenticode, that signature is embedded in the file. So when you distribute that, there is the ability to verify it both within a private and a public ecosystem, and do so using ubiquitous routes if it's public trust, or in the case of private trust, that is within a closed ecosystem, which could be a partner ecosystem within your local, within the network bounds of an organization, or within a partner ecosystem. And so what the Software Trust Manager can help with is in regards to policy controls around those key pairs, those certificates, We have profiles in place so that, when you're talking about those disparate teams that Eddie showed earlier in the slide, that, your Java team may have a different set of requirements than your Authentico team, or the team that's building firmware that's going to be deployed onto devices. So, are you using elliptical curve-based algorithms? And if so, is there a minimum curve that you feel is secure as an organization? If it's RSA, again, what's the minimum key size that you feel is safe? And do you want to go above and beyond that, even though, so there's a trade-off there between security versus performance. And those are organizational choices. And again, policy and security typically drives those. And it's better that that decision is made and for developers, so that then they can just use the profiles that are in place based on the products they're building and adhere to what is set out in the security policy of the company, rather than having to make decisions on the fly. And with big companies, of course, there's multiple product lines, multiple developer teams, all working on different things. So sometimes these policies have to be team-based, product line-based, and therefore there's a need for a flexible approach to this. It's not a one-size-fits-all. This is, and even within the enterprise, this is very much granular and something that needs to be tailored across those specific teams. So Software Trust Manager enables all of that. It takes the burden away from the developer. It gives the responsibility to that security person within the organization and helps determine the guardrails and puts those in place to help an organization keep compliant within their own sets of capabilities. So like Eddie said, again, we're solving for this policy enforcement for different personas within the organization. We have the administrators of, whether it's a team or whether they're common administrators of certificates, and making sure that those are kept current and active, right? There's nothing worse than trying to release a piece of software and you find out that just as you're about to sign it, the certificate expired last week, right? That's a nightmare. It's going to stop your product getting out the door. It's going to impact customers and it's going to impact revenue. So staying up on top of that, having the ability to auto renew those certificates so you have an evergreen build experience is music to the developer's ears. And from a developer perspective, then, of course, you don't want to be making changes to the CI/CD tools that you're using. Or a lot of Oracle community, of course, are using Oracle's OCI's DevOps, but you may be also, as Eli said, using Jenkins or GitHub Actions or something like that. And often is the case, even within a company, there will be multiple CI/CD solutions that are running in tandem with different business units, and perhaps that's due to things like mergers and acquisitions as companies come together. The other personas then of importance are those that are responsible for visibility and setting those security standards. So the InfoSec lead, setting organization policy, getting it implemented in the solution, and setting it up for the different teams that require the different things. And then that compliance analyst, more of a visibility oversight, looking in, seeing what happened, doing audits, making sure everything's okay, and not having to pester engineers all the time to say, hey, can you give me a list of all these things, when you guys are building the cool stuff that the company needs to do to keep growing and keep being successful. And so we're now going to go into a little bit of a demo as to what and how Software Trust Manager manages some of those. So from the key pair perspective, we give the developer teams a very specific group of keys and certificates that are available to them. And these can be implemented and pulled into the CI/CD pipeline. Here we're showing how using Oracle's OCI DevOps tool that you can inject the signing commands that you use with jar signer and pull that into the pipeline. And that can happen at an auto commit level. And when it happens, it's done in a hash-based way. We record it. We have a log then to show you the signing that happened. And we're able to support the visibility of that for the security folk and the auditors. But from the developer perspective, that can just be a line of instruction that's in your YAML or in your script, ensuring that everything is getting signed. And again, not that your jars or your authentic code files are leaving OCI, they all stay there. Everything is signed based on a hash. So only the hash of the file is extracted and sent up. Again, we can do this for multiple different file types. And in the demo there as well, we also showed authentic code signing happening. So using sign tool or using JSign if you're doing authentic code on the Linux environment. Roles and user setup is critical here. So setting up users is quite simple. Basic set of information, getting them the credentials that they need, which can be deployed and called from within the pipeline. So again, it's about giving those developers access, assigning them to specific and appropriate roles. If you're a developer, you want to have the developer role. If you're an administrator, you want the administrator role. And also, roles are customizable. So if you don't like the sets of permissions that we have grouped for you, you create your own, you give it an alias, you select what's appropriate for the user, and you'll be able to onboard users in a way that's specific to your organization. And based on that, then that permits those users to perform tasks within the service, whether that's scanning software, performing signing. Here's some of the global policies, right? So you're able to determine what algorithms are in place, what keys, what size, what curves, the different levels of approval workflows, whether or not you want to enforce scanning before you sign. Here's an example of us setting those up specifically then within the team construct. So again, a group of developers working on Java, giving them the right keys, certificate profile types, introducing granular controls on other things that are critical, such as approval workflows, and then having that oversight as to who can do what, right? Here's a list of your users and all the permissions that they have available to them. All right, so we're going to move on to threat detection. We flashed this slide up a little bit earlier to talk about you know, the software supply chain and which stages are critical and the checks and balances to do. So we're going to look in now at this from a threat detection perspective. So there's a couple of sensible areas in which to check for threats and vulnerabilities. First of all, there's the requirement to look at your source code. And that's not just at the source code level, but also to check for threats dependent on libraries and third-party components that are being inherited into the solution. Another good time to check is after the build, right? So you've constructed something, an artifact, a container, a jar, an MSI. Wouldn't it be great to be able to look into that and determine, actually, did anything happen during the build process? Was there any injection there that I wasn't expecting that's changed something from the source code, from the Git, until it got produced into that build? So a couple of things that we're going to talk about here are partnerships that we have and integrations that Software Trust Manager leverages to provide services to our customers. We have an integration with FOSSA, which is a software composition analysis provider. So they look at the Git, right? They look at the commit level. They're looking at what dependencies are being pulled in at the source code level. So what this is really good for is open source, you know, checking all of those libraries as to, you know, what you're dependent on. It gives you visibility into licensing issues, right? Is it the latest version? Is it a version that's safe to use? Is there a better version that you should be using? And it also checks for common vulnerabilities and exposures, CVEs. So it gives you the typical 1 to 10 score from NVD and highlights to you what's critical and what's not, so you can make some decisions on what's more important to fix at this point in time. It is limited in that the fact is it checks all of this before you build, so you have to be very stringent about your build process to make sure nothing gets injected. And again, it's not able to detect whether that happened or not. Our second partner that we want to highlight the benefit of is around Reversing Labs. They're a static binary analysis provider. And so this is about checking the compiled binary, right? They have the ability to reverse engineer the compiled binary, break it down into the components and analyze what it's made up of. And therefore, they have the ability to also check some of those third-party and integrated open source libraries, but also it checks for behaviors, right? It checks for whether the binary itself is acting in a way which could be acting in a way that is exploitable malware, or it checks some of the signatures on those third-party and open source libraries to see, you know, how long ago was that signed? Is there file rot risk associated with that dependency? And so, you know, these are very much complementary. Again, it doesn't go into the source code, right? It's not going back to check that back in your Git. So this is more of a final exam that you would do on your binary to see if anything has happened during the build process, or it could be something that you do after the build and it checks, it gives you that final check to say, yes, this is actually looking fairly healthy, or these are the things that you need to consider working on. So we like to propose these as a bit of a belt and braces type approach, strength in depth in terms of how you can ensure that the software that is passing through your supply chain is going to be as healthy as you can ensure it is. So we're going to just do a little bit of a demo now in regards to what that looks like. And we again provide a dashboard view into the different types of scans, SCA being software composition and the SBA being static binary. You can see here we give details as to what was scanned, when it happened, and then dig into the different levels of things that have been detected within a scan. So on this scan, which was performed by FOSSA as a service provider, we can see all the licensing issues that were detected. You can click into those individually and you'll be able to see what version was consumed or sorry, is implemented and what is the proposed fix in relation to that. Reversing Labs then with their static binary analysis. This is looking at deployment risks. So it's looking at behaviors. It's looking at malware, which is positioned as being actively exploited. It also provides an insight into the CVEs of those open source and third-party components where there's a signature that maps to that. And again, you can dig into this, determine whether it's a pass-fail, whether it's a P0 or a P1 or 2, what the problem is, what are the next steps, and which dependency within your binary is impacted. So it looks within that artifact and detects, in this example, it was an exe, which is bundled into this MSI that was causing the issue. And again, all of this can be made part of a workflow, right? So you can enforce, and we'll show that a bit later, that scanning happens before you try and sign. You can tightly couple code signing with scanning, and it will only allow you to sign things when they are in good standing after the scan. And again, just to talk a little bit now about, you know, what the benefit is of Reversing Labs when you look at it from a static binary analysis perspective. You know, they've got proprietary recursive binary analysis. There is no service like it on the market. It happens, you know, late in the build process. It's like that final exam to make sure that your software is healthy. It's able to do it at speed, right? It's got a very large complex, the ability to open up and analyze large complex files. It's got a huge repository of sources for checking, 25 million plus goodwill and malware records to be able to assess against, aggregating that across 40 different antivirus scanners. So very much a comprehensive set of capabilities. One thing to promote as well as we get into SBOMs, both of these providers can help you to generate your SBOMs as part of the scan results. So very much helping with that automation approach, which eases the life of a developer. All right, so let's dig in a little bit now into software bills and materials. So the next area that we're focusing on is a little bit more about SBOM. So what's driving this? Well, it depends on which side of the Atlantic you're on, really. In Europe, there's the Cyber Resilience Act. In US, there is the executive order around improving the nation's cybersecurity from the Biden-Harris administration. Both very much focused in on the right sorts of things, securing your software supply chain, securing the tools that you're using, doing best practices, making sure software is signed, building and distributing software bills and materials. And again, just a stat to be aware of is that Gartner is saying that by 2026, 60% of organizations will be requiring software bills and materials to be distributed with their software. As of 2022, it was less than 5%. Okay, so how do we help you, and how does Oracle and DigiCert work better together to improve and beef up the security within your CI/CD pipelines, whether that is in OCI running OCI DevOps, or whether, like Eli said, you could be using a Jenkins or something else on your OCI process. So DigiCert has pulled together into a workflow these three capabilities: the ability to scan and assess your software before making a decision around securing that software with a code signing signature, the generation of the SBOM associated with software that is free from risk or reduced in risk, and also the ability to apply a digital signature to that SBOM, right? Like there's no good in distributing an SBOM if it's can be tampered with, right? Therefore, you're going to have a piece of software, someone will change the SBOM, and the two no longer match up, right? So you want to be able to apply digital signature to your SBOM, make that tamper resistant, and again, verify that that came from the right source. So what does this look like within Software Trust Manager? So we have some policies that we can put in place that says, let's make the release process threat and detect and then sign, and only permit signing if the scan was a success, right? So if you find something in that software, whether you assess it with FOSSA from a software composition perspective, or reversing labs on the static binary analysis, that if either of those fails, the signature that's happening next in the sequence will be blocked by DigiCert Software Trust Manager. It won't allow you to sign something that has failed a policy check earlier in the process. And again, all of this can be incorporated into OCI's DevOps tool. There is the ability to perform the scan, then perform the signature request. And you can see here that the scan has failed. There was a detected threat within the binary that was built. And the result is then that when the signature request happens later on, that we're going to enforce a signature block and put a response in there that says this file was not signed because the corresponding scan had a result of a failed check. This also will have the alternative approach in that if the scan is a success, then nothing was found that was it should cause concern. Therefore, the signing is permitted to happen. And here you can see the signature was permitted, happened automatically. And again, this is all part of your automatable CI/CD process in OCI DevOps or whatever tool that you're leveraging. And so that brings us just to a conclusion. Again, DigiCert's delighted to work with OCI on bringing our two solutions together. Software Trust Manager is part of the DigiCert One portfolio, and it is running in OCI. So, if you're in OCI house and you're running everything there, we have the ability to meet you there, to deploy all our DigiCert tools in a way that integrates with those tools from Oracle, give you that ability to do threat detection, secure code signing compliantly, and to generate and sign SBOMs when that is part of your requirements within your industry. So I'll wrap up there.
Well, I guess while we're waiting and kind of closing things out, I just wanted to take a minute to thank Dave and Eddie for joining us today. Fantastic overview, fantastic deep dive on some of the service capabilities and the integrations, and really looking forward to taking this forward. We're going to hopefully do a few more sessions and explore more of the integration, the partnership, the functionality. So stay tuned for that. And big thanks to Tara for helping put this all together. Thanks again, and happy holidays to all.
Thanks everyone so much for joining us here today, and we hope to see you at the next one.